Chemical Technology Group, 1505. My supervisor is Alexaнян K.G. She is a candidate of chemical sciences. Let me introduce my graduation work on the topic of synthesis of dicyclobamic acid esters and research of their effect on geological properties of lubrication oils. The typicality of my work is the following. Currently, great attention is given to the problem of environmental protection. Therefore, oils should have high operational and ecological properties. Nowadays, in the chemistry of motor oils, appeared oils of the type low subs, that is, oils with low level sulfated ash, phosphorus, and sulfur. In the Institute of Petrochemical Synthesis of Russian Academy of Sciences, much attention is paid to the dicyclobamic acid derivatives, and it has been proposed to use ashless derivatives of dicyclobamic acids to improve the operational and ecological characteristics of oils. The purpose of my work is to obtain ashless additives for lubricating oils in order to improve the operational and ecological characteristics of oils. The following tasks were set. First, to choose a technique for the synthesis of dicyclobamatic esters. Second, to synthesize a number of dialkyl diethylcarbamate with different radicals. Next, to determine the physical and chemical properties of obtained compounds. Next, to study the activity of esters in oils in the processes of friction and wear. And finally, to draw conclusion about possibility of their use in commercial oils. We studied a number of methods for the synthesis of esters and chose some of the most optimal. The first method is taken from the book by Berko. The synthesis is done in two stages according to the reaction shown in the slide. We got the right substances, but yield was low, about 30%, and the conversion was incomplete. Second method was taken from journal Organic Letters. This is a method carried out of one stage and of the reaction of amine, carbon disulfide, and haloalkane upon heating without the use of a solvent and a catalyst. We obtained a compound with a yield of 14%. Next method. The third method used was developed in the Institute of Petrochemical Synthesis of Russian Academy of Sciences. As in the first method, synthesis is carried out in two stages in similar reaction, but the conditions of experiment are different. Using this method, we obtained 7 esters with different radicals. Compounds are obtained with high yield and clear boiling points. Our compounds are characterized by chromatography mass spectrometry and spectrometric analysis. By the result of this analysis, it can be seen that some of the compounds are pure compounds and some are blends. Also, an elemental analysis was made. The analysis data say that 4 esters are individual compounds and 3 products are mixtures. The effect of the obtained decyclocarbamic acid esters on the topological properties of lubricating oils was studied. Anti-wear properties are determined by the diameter of the wear scar. There is the dependence between the diameter of the wear scar and concentration of esters in oils in the slide. It can be seen that when dialkyl-deuteric is added in optimal concentration, the diameter of the wear scar increases. Next, the adding capacity is characterized by a critical load. There are diagrams showing the increase in critical load when adding esters in oils in this slide. The influence of synthesized compounds on anti-friction properties of oils is characterized by coefficient of friction. The diagram shows that coefficient of friction decreases with the addition of esters. To sum up, we can draw the following conclusions. First, we obtained series of dialkyl decyclocarbamic acid esters, and some compounds are pure substances and some are mixtures. Next, we determined physical and chemical properties of our compounds by elemental analysis and chromatography mass spectrometry. And finally, the result of the study of topological activity of the obtained compounds show that dialkyl-deuteric derivatives improve the Brownian capacity, increase the anti-wear and anti-friction properties of different oils. Thank you for your attention very much. If you have questions, I will answer them with great pleasure.
Of course, we do have questions. Thank you. Yes, thank you very much. And now, we, the board members, can now ask our questions. Yes, please.
My question is about Налетова. Did you use these substances as a lubricant? Did this for the first time or not?
Thank you for your question. Yes, in Russia, we used our compounds as additives to lubricating oils first time.
In Russia? No.
In Russia.
Yes, please.
What kind of properties you classify as environmental, friendly, or ecological, as you see?
we try to find additives in order to exchange commercial additives, which is the alkyl diethyl phosphorate of zinc, which have negative properties of ecological.
You mean toxicity or other properties? What do you mean?
Our compounds is
Maybe do not contain a heavy metal or other components.
Our compounds have low level sulfate, phosphorus, and metal. And these are more ecological.
Okay. Okay, sounds good. Any questions?
My question is about tribology, the properties of your additives. We can control tribology properties for well testing machine, but on your presentation, we saw anti-friction properties. What kind of type of tribometer you use in your work?
We used a trigonometry machine. I don't remember name.
Not for ball testing machine.
Not
Some other.
Other.
Okay, and can I follow up on this question, please? The materials which you have used are very comparable to the alkyl diethyl phosphate of zinc. Have you compared your substances with the traditional additive? And if you have compared them, have you shown us the comparison so that we know that you are better or worse than the existing additive?
We didn't compare our compounds with the alkyl diethyl phosphate of zinc, but practically. But according to literature data, our compounds have low properties than the alkyl diethyl phosphate of zinc.
So the zinc substance is better. Is
Yes.
that what you say?
More efficient.
More efficient, and that's what we could see as well on your graphs, that they are not very much comparable to the traditional one. So what is then your outlook for the future of your substances? Do you think they could replace the zinc, or that is coming in the future one day?
We will plan synthesize other similar compounds with different radicals, maybe radicals of phenol, and we think that they can show better results.
There was one thesis yesterday or the day before yesterday I was listening to, and they were looking at the alkyl diethyl phosphate of molybdenum.
Yes.
And that was impressive because it was better than zinc actually. So what are the advantages of your substances then?
The alkyl diethyl carbamate of molybdenum have good antioxidant activity. and so have anti-wear properties, but main is antioxidant activities.
Okay. And maybe last question, maybe something more. But my question is, this is quite a sizable work, yeah? So what part of this work was done by you personally, yourself? What part of this work was done by yourself?
I do this synthesis myself, and I carried out experiment on 4-ball tubological machine, but on tubometry machine I didn't experiment.
Okay, okay, that's okay. Any more questions? Thank you very much. Thank you. Anna Viktorna Налетова. Okay, you're welcome. So this is the diploma work of Anna Налетова, and this is also the bachelor degree work, and we have a reference letter from Dr. Alexaнян, again the head of the
So good afternoon.
1 second please, just me then you.
Okay.
And actually the reference letter is very positive, so please Anna Viktorna, the floor is yours. Now you can start.
Thank you. So good afternoon ladies and gentlemen. First of all, let me introduce myself. My name is Anna Налетова. I present the Department of Organic Chemistry and Petroleum Chemistry, and the theme of my work is synthesis and analysis of antioxidant additives based on methylfluoroglycerol, fuels and oils. So, and now purposes and tasks of the work. The main purpose of the work is the synthesis of new effective antioxidant based on methylfluoroglycerol. To execute assigned purpose, we should realize such tasks as, first of all, analysis of the literature on the theme. The next one is realization of the synthesis. The next is analysis of getting compounds. It is very necessary, and test on antioxidant ability of synthetic compounds. So now, well, first short introduction of the work. So why did we choose the synthesis of antioxidant additives? First of all, antioxidant additives play a very important role in fuel storage of petroleum and petroleum products, etc. So chemical and thermal oxidative stability is one of the main requirements in the quality of petroleum products. Due to technological evolution, it makes sense to develop new, more effective antioxidant additives, replacing outdated hydroxytoluene. So, on this slide you see the main and most popular industrial additives. There are 4 groups. Substituted phenols, ironol, number 2 containing amine, so PPD. Number 3 is metal deactivators. So a few words about metal deactivators. So metal deactivators are a special phenolic antioxidant containing functional group that enable them to complex with and make them to highlighted complexes. So you see the highlighted complexes with a copper. The next one is zinc dialkyl phosphate. But these popular additives is very cheaper, but this popular and cheaper additive can spoil the system of your afterburner in your automobile system. That's why a lot of manufacturers are looking for new, more effective antioxidant additives like substituted phenols and metal deactivators. In our work, we decided to synthesize substituted phenols and metal deactivators. Now, practical part, synthetic part of the work. So, we choose parent compound. First of all, we choose methylfluoroglycerol, but some synthesis, for example, of metal deactivators, we do with fluoroglycerol. It is a relative compound to methylfluoroglycerol. So, why do they choose it? First of all, it's a special phenols. You see, we can make antioxidant additives like substituted phenols and metal deactivators. The next one, with decision of problems with utilization of 3-nitrotoluene, it's because methylfluoroglycerol is the product of transformation of 3-nitrotoluene and 3-nitrobenzene for fluoroglycerol, and heightened interest on this compound in organic chemistry nowadays. So, synthesis number 1. we get parent compound methylfluoroglycinol during 3 hours with aniline with hydrochloric acid is the catalyst of the process. We get compound number 1. You see the yield rate. The next one is we decided to synthesize a special class in organic chemistry. It's coumarin. So coumarin is a special class in organic chemistry. We've got information that this compound used like antioxidant in food products, and we decided to test them on oils. So these are the reaction of condensation between acetic ether and acetic acid during 1.5 hours. With the methylfluoroglycinol. You see compound number 2 and the yield of it. And we decided to compare the synthesis number 1 with the synthesis number 3, but we do it with fluoroglycinol. We get compound number 3. The yield became higher, as you see on the slide. So, to prove antioxidant ability of a synthesis compound, we do it like in plants, first of all, APSM1M, we do it in BP neft, and petrotest, we do it in Department of Chemistry and Technology of Lubricants and Chemometallurgy. And then we made the titration by state standard number you see on the slide. So, test on accident ability, you see this chart provides about this information. So our compound, for example, compound number 1, compound number 2 and 3, became more effective than industrial additive iron oil, so you see on the slide. And these are the efficiency as to oil without additive. This chart provides information about the oxidation during the time of oxidate. So our compound became higher and have more effective than iron. So the next group of the synthesis. So we do it with methylfluoroglycinol, with ethyl nitrate, with acetic acid, and we get compound number 4. The yield became higher as in the synthesis number 2 and 3. And we decided to recover them with hydrogen hydrate and with methanol during 6 hours. So we get compound number 5. The yield became more high. So we tested on ability of synthesis compound. We do it in the plant petri test, but we compare with industrial additives like DF11 and A22. And as you see on the slide, our additives became more good efficiency as to oil without additives, nearly DF11 and A22. So synthesis number 6. We do this synthesis because we get middle compound, which we use with the synthesis number 7. So first of all, 3 words about synthesis number 6. You see, we do it with fluoroglycinol, with concentrate during 2 hours, with acetylfluorine, and the catalyst was aluminum fluorine 3. So we get compound number 6. As you see, the yield became very effective, and I think it is very good. So the synthesis number 7 we do with compound number 7 with aniline during 22 hours with ethanol, and we get compound number 7. As you see, we have a CN bond, and these additives can be used like metal deactivators in oils. So synthesis number 8, we do with compound number 6, but we change aniline to octadethylamine during 24 hours with ethanol. We get compound number 8, and the yield became like this. So we tested them on antioxidant ability. So we compare with DF11, this is the industrial additive, and our additives became like efficient like DF11. That's why we can use it in industry like metal deactivators. So the conclusions of the work. First of all, we get 6 new compounds in organic chemistry based on methylfluoroglycinol and fluoroglycinol. So we developed methods of synthesis of antioxidant additives based on methylfluoroglycinol and fluoroglycinol. And all of the synthesis compounds were tested on antioxidant ability. All of them indicate high quality. Thank you for your attention. If you have some question, please ask it. I will answer it with great pleasure.
All right, thank you. Thank you. Okay, now our questions, please. Lady Nikolaevich.
We know that dibutyl paracrisols work under the temperatures near 90 usually. Dithylphosphates under 120 degrees. What temperatures you recommend for your antioxidants?
I recommend like dithylphosphate, like these temperatures, work with my additives.
Near 120.
Yeah.
What was the analytical method or way to determine your target substances and then calculate the yield of reactions?
So we just by we count it like in special premise, so just in lab. For example, you take out. Yeah.
What analytical instrument we use to determine your target substances in all 6 reactions?
In 6 reactions, so as a special.
There was byproducts in reactions.
No, we just to prove the clearness of our products, we do it recrystallization of it, and this yield is after crystallization, and we can say that our additives are cleanest. So that is a special yield of our determinate product compound.
Only measurement
Yes.
after crystallization.
Yes.
Can I also ask you a question on, you have synthesized quite a number of substances and then you compare them with the traditional additives, right?
Yeah.
So in first case, you have chosen ironol, right, for one or two first few substances. But later in the work, you started to compare them with some other substances, like, for example, TF11. Why is that?
So first of all, I decided I've made 3 groups of the syntheses, and I decided to compare with traditional ironol because it's substituted phenols, and then I decided to compare with very popular, effective, and etc. Dialkyl phosphate, and I compare the tests between 2 groups. So our additive can use like dialkyl phosphate and ironol. That's why I choose the different additives.
So generally, it would be beneficial if you could put into one table all of your substances and also all 3 of the additives which you compare them to, right?
Yes, but it's different groups of the synthesis,
So,
and I decided to.
Yeah,
To
well,
increase
then
the
it could be just more consistent if you have the one and the same comparison base, because then we can really see what are the advantages of your substances. So which one is the best?
As for me, the best one is based on methylchloroglycinol. It's compound number, if I'm not mistaken, 4 and 5, because the efficiency became 55%, which is very, I think, effective and high. And the next, my favorite, it's metal deactivators. It's synthesis and compounds number 7 and 8.
So how good are they? Are they better than commercially available substances?
Yes, I think that's really better than.
Okay. Are they cheaper than commercially available substances?
So they are cheaper because we don't buy our product. We don't do just hydrolysis of nitrotoluene, and so we just buy already done product, and our products which we do with the synthesis are cheaper.
You're sure?
Yeah.
Okay, good. It's always good to be sure. Some more questions, please? Yes, please.
How did you prove your substance structure?
So I
Can you
proved
sound spectra?
yes. So I proved structure by mass spectrum, PMR, and IK spectrum. In my work, I have PMR spectrum of compound number 3. So these are the peak of amine group. These are the same in this structure. These are the peak of the ring of benzene in the center, and these are the peaks of this, and these are 4 pieces. So that's why they proved our structure by PMR, and we get the information that our compound is clean.
Maybe, yes, please.
Would you attribute strong field peaks on the right?
These are the solvent, and these are the salt with the water.
Which solvent?
This is the solvent, and this solvent with the water.
What solvent is it?
DMCO.
DMCO.
Yes.
And if we come back again to comparison of your substances with the traditional ones, the concentrations you were using, why did you use these concentrations in oil?
Oh, first of all, the first of the device of my supervisor who helped me, and that's why we have different yields. And I would like not the mixture of the synthesis, but I want to get one from the synthesis and to test them.
So you had no enough substance, yeah? That's why the concentration is low.
But I just
That's what we're saying. Okay, so that is why the alkalinity of phosphate of zinc you have in 0.05%, which is not a typical concentration for this.
But I would just want to compare with like this.
Okay. All right. Any more questions? No. Thank you. Thank you. Anna Konstantinovna. So. You ready? Okay, so we have the diploma work of Anna Konstantinovna Котцова, and this work was performed under the management of Doцент Давлетшина. We have also the reference letter from the scientific leader of this work, and it is fully positive again. So please, Anna Konstantinovna, you're welcome.
Good afternoon, my name is Anna Котцова. I am a fourth-year student of Chemical and Environmental Engineering faculty, the Department of Chemicals for Oil and Gas Industry. Today I would like to present my graduate thesis, the study of quartz dissolution in fluorine-containing compositions. Nowadays, the development of sandstone formations appears to be an uneasy issue. Most oil fields are at the last stages of the development, and wealth productivity decreases. The most widely used technology for oil stimulation is acid treatment technology. Quartz is the main mineral of sandstone formations. It makes up to 80% of its composition. Therefore, it is one of the main tasks for the development of acid compositions to study quartz dissolution kinetics in various acids. Thus, the first subject of my research is quartz, represented in 2 different forms, which are quartz sand, crystalline form, and amorphous form, quartz glass. And the other subject is an acid composition. It plays 2 main roles. It dissolves the rock, the basis of which in heterogeneous rocks is quartz, and it maintains a low pH level to prevent the creation of precipitate. Mud acid is the most commonly used chemical agent for acidizing of sandstone formations. It consists of hydrofluoric and hydrochloric acids and has certain disadvantages, such as it is highly corrosive and toxic. Therefore, one of the main ways to develop an acid treatment technology is to substitute this standard liquid acid with their dry analogues, which are ammonium fluoride, ammonium bifluoride, and sulfuric acid. The aim of my research is to develop a dry acid fluorine-containing compositions for sandstone formations acidizing. The objectives of my research are to study quartz dissolution in hydrofluoric acid, ammonium fluoride, and ammonium bifluoride, to study quartz dissolution in fluorine-containing acid mixtures with hydrochloric acid, and to study quartz dissolution in dry acid mixtures, ammonium fluoride, ammonium bifluoride, and sulfamic acid. Methods of the research with the use of quartz sand and quartz glass are very similar, yet have some important differences. The first step is to prepare an acid composition. Later, sampling has to be done, and the material has to be exposed to a certain volume of acid composition. When reaction time is over, it is necessary to flush quartz with water and dry it in the oven at 105 degrees centigrade. Finally, the quantity of dissolved glass and the rate of dissolution are to be determined. The first series of experiments was conducted with the use of quartz sand and fluorine-containing individual solutions. That was done for the reason that structure of quartz sand is crystalline, so it is similar to the natural one. It has been found that 5% solution of hydrofluoric acid and equivalent solution of ammonium bifluoride show the highest dissolving ability, while ammonium fluoride appears to be slightly reactive when contacted with quartz sand. As for the rate of sand dissolution, it dramatically decreases after the first 30 minutes of dissolution. This might be connected with the activation of sand surface. The research on quartz sand involved many manipulations, and experiments in general were very complicated. For that reason, the next series of experiments was performed on quartz glass. Experiment procedure on quartz glass is much easier than with sand. This method has practically no material losses during flushing, and it is much easier to provide full contact of acid with the material. So the same solutions were analyzed for glass dissolution processes. Out of all fluorine-containing acids studied, 7.13% ammonium bifluoride solution, equivalent to 5% solution of hydrofluoric acid, appeared to be the most active one. As for ammonium fluoride solution, its reaction with quartz sand in water solutions appears to be very slow and is practically unnoticeable under normal conditions. Also, graphs showing the expenditure of acid in terms of reaction times were built. According to these graphs, ammonium bifluoride reacts with quartz glass at a high speed. In general, the speed significantly increases with the rise of the temperature, but for all acid mixtures remain practically the same through time. In industry, standard acid treatment technology at low reservoir temperatures is performed with the so-called mud acid, a combination of 12% of hydrochloric acid and 3% of hydrofluoric acid. That is why the next step was to study quartz dissolution processes in compositions containing 12% of hydrochloric acid and 3% of hydrofluoric acid or equivalent amount of ammonium fluoride. According to the data presented, addition of 12% of hydrochloric acid has an insignificant impact on ammonium bifluoride's dissolving ability, while ammonium fluoride, which had practically no dissolving ability in water solutions, increases its activity. At 40 degrees centigrade, its activity is already higher than the one of ammonium bifluoride and can be compared with mud acid. Later, it was decided to study the activity of ammonium fluoride with the equimolecular amount of hydrochloric acid. We noticed a slight increase of activity connected with the decrease of hydrochloric acid amount. Further investigations show that activity of both solutions peak at the amount of half equimolecular of hydrochloric acid. This might be explained by the shift of equilibriums in these reactions. On these slides, you may see summarized results of the study of fluorine-containing acid mixtures with hydrochloric acid. Mixtures of ammonium fluoride with the half equimolecular amount of hydrochloric acid show the highest productivity. Moreover, a composition based on ammonium fluoride is a more active one. Such activity may be explained by a higher amount of ammonium cation in the solution when compared to ammonium bifluoride solution. The aim of my diploma work is to develop a dry acid composition. That is why our next step was to substitute hydrochloric acid with sulfamic acid and to study dissolvability of compositions in terms of concentrations of sulfamic acid. We found that regularities remain the same at 20 degrees centigrade, and compositions containing half equimolecular amount of sulfamic acid are more active. Also, the composition based on ammonium fluoride is more active than the one based on ammonium bifluoride. As for 40 degrees centigrade, it becomes difficult to recognize any difference between equimolecular and half equimolecular amount containing compositions based on ammonium fluoride and bifluoride. This might be explained by accelerating hydrolysis of sulfamic acid with the rise of the temperature. Thus, compositions based on ammonium fluorides with hydrochloric and sulfamic acid in half equimolecular amount show higher productivity than the standard mud acid. So, the conclusions of my work. First of all, quartz glass, despite its amorphous form, according to these studies, provides comparable results and is suitable for proving the pattern of quartz interaction with acid compositions. Individual acid's activity decreases in a row: ammonium bifluoride, hydrofluoric acid, ammonium fluoride. Ammonium fluoride solution without acid active is merely active, but its dissolvability increases significantly with an addition of hydrofluoric acid or sulfamic acid. Maximum activity is shown by compositions based on ammonium fluoride with an addition of hydrochloric or sulfamic acid in half equimolecular amount. And dry acid compositions containing 5.55% of ammonium fluoride, which is equivalent to 3% of hydrofluoric acid, and half the equimolecular amount of sulfamic acid, which is 7.28. And another composition based on ammonium bifluoride, an equivalent concentration to 3% of hydrofluoric acid and 3.64% of sulfamic acid, are more effective than the standard mud acid by their dissolvability. And further investigations will be connected with the study of these dry acid compositions and the study of its compatibility with reservoir fluids and coefficients of the bottom hole zone. And further, it's necessary to see if it is possible to apply these dry acid compositions to enhanced oil recovery processes. Thank you for your attention. I will gladly answer all your questions.
Thank you very much. Okay, our questions, please.
How did you determine dissolving ability?
I determined dissolvability by the gravimetric method. We measured the mass of a quartz sample or before the reaction and after. And this is how we determine the dissolvability by the quantity of dissolved glass at our site.
Okay, thank you.
What kind of equipment we can use for transporting your exits to inside oil fields?
That is actually.
It's mean. What do you think about electrochemical corrosion on internal surfaces of pipes and pumps and other?
Well, the advantage of these acids is that they are in a dry form. If they in some sort of a powder, or as you can see it in the picture, and that is a huge advantage. As during the transportation, we can use simple bags or special. We do not need special equipment for transporting it in a liquid way. That reduces the level of corrosion in pipelines, and it also reduces danger for people and for environment. And it isn't right.
So in fact, what you say is that these compositions could be prepared on site.
Yes, it is actually the
whole idea. Right?
Yes.
And just following up this idea, how are your substances or compositions better than the traditionally used ones? Yeah?
Yes, as I have shown, they are better than the standard mud acid, which contains 12% of hydrochloric acid and 3% of hydrofluoric acid. So its dissolvability is higher. So by dissolvability, it is more effective. But still, we need further investigations, like compatibility with reservoir fluids, as dissolvability is the first thing to know, but not the only one to understand if an acid composition is suitable for enhanced oil recovery.
Okay. And then if we say we can apply them directly straight away, would it be more economically efficient?
Yes, in fact, I found that 1 cubic meter of acid prepared from hydrofluoric acid and 1 cubic is more expensive than 1 cubic meter prepared of acid prepared from ammonium fluoride. So these acids are cheaper than the standard acids used nowadays. Well, mostly used.
Yes, please.
Let's look on slide number 6. How can you explain the sharp decrease in reaction rate this time?
Well, it is probably connected with partial precipitation because according to the reaction, of course, of silicon dioxide with hydrofluoric acid, some precipitates can be formed, and it should be noted that surface of sand is much greater than surface of glass cylinder. That is why patterns of rates are different, and probably some deactivation can be caused by partial precipitation, and that is why rate decreases after the first 30 minutes.
Precipitation of what?
Sorry?
Precipitation of what? Reaction products?
Yes, of reaction products with silicon dioxide and hydrofluoric acid formed from ammonium chloride.
Probably to follow up on this question, we see quite a lot of sequences, we see quite a lot of experimental material here. You made the comparison based on time and different concentrations. But have you tried to look deeper into the process? Can you make any judgment of the mechanisms of the chemistry of the processes which you are looking at?
We noticed, for example, that ammonium fluoride itself, the blue lines, it does not interact with silicon dioxide. That proved there existing information about the mechanism of dissolution of silicon dioxide, which says that a certain proton is needed for the start of dissolution processes. So this series of experiments actually proved it. And also, literature says that ammonium bifluoride's dissociation degree is higher than the one of hydrofluoric acid, and that is probably why its activity is higher than the one of hydrofluoric acid. So this is the conclusion that we made out of this data.
What are the prospects of this work? What are the next steps actually? What we're going to do next?
Well, next we plan to analyze the dissolution not only of quartz but of other minerals of sandstone formations with these acids. Then we plan to build a model out of different minerals and to see how it will interact with the model when several minerals react at the same time with this acid. And also it is necessary to understand the compatibility of these acid mixtures with reservoir fluids and with collectants of the bottom hole zone, which also include quartz and clays and other minerals.
Any more questions? No? Thank you. Thank you very much. Are you ready?
Yes.
Okay, good. Veronika Vadimовна Shirokova would like to present to us her diploma work, which was performed under the scientific leadership of Professor Magada. And this diploma work has also a reference letter of the research leader, and this is also quite positive. So, please, the floor is yours.
Good afternoon, esteemed members of committee and audience. Let me present to you my graded phases of the next film, the study of gelling agents for enhanced oil recovery technology. Nowadays, enhanced oil recovery methods are widely spread. It is related to the fact that the part of unrecovered oils in reserves has raised. Also, conditions of petroleum reserves has changed for the worse, and there are more low permeable layers in reservoir. Diverted technologies are essential to solve this problem. And when it's spoken about diverted technologies, it is intent injection of chemical that can form gel in reservoir, block flash zones, and divert the flow of injecting water to low permeable layers. For a long time, single compositions have been used. However, their efficiency has been far from desirable. Therefore, integrated technologies have become widely practiced. They intend joint injection of several agents. However, they also have their own disadvantages, and one of them is fast gelation, whereby gel forms near injection well. This occasion leads to breaching of injecting water and drowning of productive well. In such a way, these technologies have been modified, and technologies based on long-distance gelation have been developed. One of them is Sixel technology, which intends next steps: injection of polymer solution, injection of sediment forming composition, and injection of polymer solution. Such operating sequence promotes gelation time increment and low water mobility. Nevertheless, high absorption of polymer solution in porous media have a negative impact on efficiency of this technology. In light of the foregoing, the purpose of the research is the study of gelling agents, especially cross-linked polymer systems, for enhanced recovery technology Sixel. And the objectives of the research are thermal resistance research of polymer solutions, selection of pH optimal concentration and mark, dynamic adsorption research of optimal pH solutions, sediment forming composition behavior in porous media research, integrated technology behavior in porous media research, and the capability assessment of optimal pH solution application. For reaching the purpose of the research, next subjects have been chosen. They are 2 marks of polyacrylamide, sulfonated and hydrolyzed, sediment forming composition, and salt water with high mineralization. All studies have been carried out according to the next operations. They are preparations of salt water and solutions, and rheological studies and seepage studies. At the first stage of the research, thermal resistance research have been carried out, and there are results of this research on the next slides. As you could mention, in the case of linear hydrolyzed polyacrylamide solutions in salt water, incorrect data have been received. It means that hydrolyzed polyacrylamide interact with calcium ions in over-cross-linking reaction, and this occasion leads to degradation of PA viscosity properties. So in such a way, it could be said that the optimal mark of polyacrylamide is AN125SH due to its high resistance to mineralization at high temperatures. Selecting optimal concentration of polyacrylamide, dynamic viscosities of linear and cross-linked solutions have been compared. As you can see, for concentration of 0.03%, linear and cross-linked solutions have minimal difference in dynamic viscosity. It means that cross-linked solution have low viscosity enough for pumping it into an uninvaded zone of reservoir. So the optimal concentration of polyacrylamide is 300%. At the second stage of the research, dynamic adsorption studies of optimal pH solutions have been carried out. Simplified scheme of filtration unit is presented on slide. During test in core holder steel tube, filled with quartz sand has been fixed. At first, salt water have been filtered through porous media to saturated, and then PA solutions have been pumped. During filtration, pressure difference across tube have been measured with differential manometer. After injection of salt water, initial characteristics of porous media have been estimated. They are pore volume, porosity, and permeability. They are presented in a table. As you can see, these characteristics are approximately identically for linear and cross-linked solutions, so we can compare behaviors of these solutions. According to the results of filtration, plots pressure difference versus injection relative volume have been constructed. And on this basis, values of residual resistance factor have been estimated and specific dynamic adsorption have been calculated. For linear solution, dynamic adsorption equals 53,000 milligrams per square meter, and for the cross-linked it equals 31,000 milligrams per square meter. So, in such a way, it could be said that 308% cross-linked sulfonated polyacrylamide solution is less absorbable in porous media than linear one. And there are some reasons for it. First of all, in cross-linking reaction with chrome ions, polyacrylamide forms a complex composition due to its functional groups. This occasion prevents functional groups of polyacrylamide from interaction with surface of porous media. Moreover, chrome ions fix sulfonic acid groups in a three-dimensional polymer network, which keeps molecules in volume. So in sum, we have a low absorbable polyacrylamide solution that can be injected through porous media without loss. At the third stage of the research, behaviors of traditional and integrated technologies have been researched and compared. On slides, a possible mechanism of gelation is presented. As you can see, formation of polymeric particles depends on pH, so it is necessary to keep pH on certain value. On this slide, action of integrated technology is described. As you could mention, where PA solutions have been injected before and after sediment gel forming composition, with a view to protect it from dilution. During tests, also previously salt water have been injected through porous media, and initial characteristics of porous media have been estimated. As you can see, for traditional and integrated technology, they are approximately identical. So we can compare the behaviors of these technologies. Also, during injection, initial and final values of pressure difference have been recorded, and on this basis, values of residual resistance factor have been calculated. As you can see, for integrated technology, value of residual resistance factor is more in 1.6 times. So it means that integrated technology is more efficient in 1.6 times than traditional one. It also proves that PA solution can protect our sediment gel forming composition from dilution. On this slide, the main conclusions to the research are presented. First of all, thermal resistance of PA solutions in fresh and salt water have been researched, and optimal concentration and mark of polyacrylamide have been selected. The optimal mark have turned out to be the AN125SH sulfonated polyacrylamide, and the optimal concentration is 308%. Secondly, dynamic adsorption of optimal polyacrylamide solutions have been researched, and cross-linked PA solution turned out to be less absorbable than linear one. In our final stage, behaviors of traditional and integrated technologies has been researched and compared, and the integrated technology turned out to be the more efficient, and also protective properties of polyacrylamide solution have been proved. In sum, it should be said that optimal polyacrylamide solution can be applied in 6L technology. That's all. Thank you for your attention. If you have any questions, I would like to answer them.
Thank you. Thank you very much. Our questions, please. What do we start with? I should mention that this looks like a PhD work rather than a master's diploma, right? To many different aspects. So my congratulations with that. But I still have a question. If I may ask, this is a significant and sizable job. What part of it was performed by you personally, you yourself?
Approximately all of the parts of the job was done.
So you've done it all yourself, right?
With advisor.
Of course, yes, sure. But technical, there is quite an experiment behind it. So all experiment was performed by you personally,
Yes.
right? Okay. So, yes, I could also see there were field studies there, or this is only the next stage of this research. Are you coming to the stage of the field studies?
No. There has been only seepage studies in laboratory, but this the purpose of this work was the proof of polyacrylamide solutions properties. This technology would be soon patented and maybe will be used in field.
Okay. All right. Yes, please.
What did mineralized water influence for your polyacrylamide activity?
Hydrolyzed polyacrylamide turned out to be less resistant to mineralization because it interacts with calcium ions in salt water, and with occasion led to degradation of pH properties. It is lowering of dynamic viscosity. And sulfonated polyacrylamide turned out to be resistant to mineralization.
Could you please show the picture 9 and more closely describe your experiment? How you measure the pore volume?
In a core holder, steel tubes filled with quartz sand. It was a certain mass of quartz sand. And when we at first inject water through porous media, we received a certain volume. And permeability have been estimated by a difference between a first volume of salt water and the final volume of salt water.
Is it standard method? Is it standard method?
Yes.
Okay. Thank you. And can we come to the slide 14, please? Yeah. And here we can see you compare your integrated technology, right, with the traditional technology. So, what is the traditional technology? What is the difference between the traditional one and yours?
Traditional technology intends injection of a single composition in reservoir, and integrated technology intends joint injection of several compositions. So, as a traditional technology, sedimentary forming composition have been used, and as integrated technology, polyacrylamide solution plus hydrogen forming composition have been used.
Okay, so this is clearly a much more complicated project, right? And what can you tell us about the economics of potential use? Is it still feasible to use your method in the field? Is it easier? Is it more complicated than traditional technology? And therefore, would the people apply it in the end? Or would they still stick to the traditional method?
It is more complicated, but it's more effective, and we don't need special equipment for preparation of these solutions. So we don't have any problems with economics, I think.
All right, okay. Thank you. Any more questions? No? Thank you very much. Ready? Екатерина Станиславовна Котцова. So this is about this is the master's dissertation, which was performed under the leadership of Dr. Bandasara, and the file also has the reference letter from the scientific leader, of course, which is positive, and also from the LFA International Head of the Department of Science, Mr. Charitsa, which is also positive and shows, underlies the significance of this work. So please, yes, welcome.
Good afternoon, ladies and gentlemen and members of examination board. My name is Ekaterina Trapeznikova, and I'm honored to present you my graduation thesis, which is analysis of metal working fluids formulations. What is a metal working fluid and why to examine its formulation? The metal working fluid is a range of oils and water-soluble liquids that are used to cool and lubricate metal work pieces when they are being processed. From the chemical point of view, metal working fluid is a complex mixture of chemicals. Why to examine their formulation? The thing is that, unlike motor oils or other lubricants for metal working fluids, there are no ready-made additives packages, and the producer has to select chemical compounds himself in order to reach required properties. The Russian metal working fluid market is not that big and prosperous at the moment, as many consumers prefer products of foreign origins. Taking it into account, and in order to accelerate the process of formulating a new metal working fluid, and in order to prevent the shot in the dark when formulating metal working fluid, it could be useful for the Russian producer to examine any foreign product and try to guess its composition. And we have to take into account that this composition is not shown on the label of the product, and it cannot be found in its technical documents. So the purpose of my research work is to work out an algorithm and a number of recommendations that will provide the means of identifying chemical formulation of the metal working fluid. In order to do this, I needed to analyze typical components used in metal working fluids formulations, to analyze methods of identification of chemical compounds, and to examine any metal working fluid and propose its possible composition. So here on the slide, I would like to show you typical components used in the formulations and their classification from the chemical point of view. So we can see that metal working fluid may contain paraffin and naphthenic oils, amines, ethanol amines, sulfurized oils, sulfonates, nitrogen, phosphorus containing compounds, esters, alcohols, glycols, and metal containing compounds. So here is the algorithm of analysis I propose, and it consists of 4 steps. Let's take a closer look at each of these steps. First of all, we need to identify the type of metal working fluid. They are divided into 2 groups, mineral oil-based and water-soluble, which are represented by emulsions and solution. We check it by simple interaction with water. In the case of mineral oil-based, we see two separate phases, oil and water, and in case of water-soluble ones, we see formation of emulsion or transparent liquid. So step number 2 is measuring of general characteristics such as viscosity, base and acid number. We measure viscosity by viscometer, and viscosity shows us lubricating properties of metal working fluid. Base number and acid number point on the content of alkaline components and acid components accordingly. Some metal working fluids may not contain acids, and we can prove it by measuring acid number. Step number 3 is separation of water and oil phases. It is applicable for emulsions. I propose this step because in some further methods of analysis, water may cause interference signals and complicate the identification of compounds. So we better divide these 2 phases. We can complete it using acid decomposition, interaction with hydrochloric acid, and after mixing these 2 components, we see formation of water phase and oil phase. We also need to take into account what components will be in each phase. So the oil-soluble components are salicylates, benzotriazole, esters, alcohols, for example. It depends on the metal working fluid formulations. And also the water-soluble components such as amines in the form of ammonium salts, ethanol amines, borates, and formaldehyde, which are used as spice. Step number 4, the most difficult and important one, is separate analysis of oil and water phases. So the oil phase we may analyze using the following methods. As many metal working fluids may contain nitrogen compounds in their formulation, we can identify nitrogen by Kedel method, which is based on the interaction of sulfuric acid, and if there is nitrogen in the compound, ammonia evolves. We can also use chromatography, but this method may be useful for us in terms of seeing how many components are there in a mixture. Identify certain chemicals will be rather difficult because there are many of them and we have no idea what they may be. The simplest and the most informative method in this task would be IR spectroscopy, in my opinion. Using this method, we can identify functional groups such as amines, OH, esters, and maybe some others. And we can also use atomic spectroscopy to identify elements such as zinc, calcium, sulfur, phosphorus, and other elements used in metal working fluids formulations. And knowing the elements, we can guess what compounds are there in the metal working fluids formulation. As for the water phase, we know that boron components are soluble in water, and we may identify boron components by color test with the use of cuprin paper. We can also use identification formaldehyde test to identify formaldehyde, which is the interaction with cuprin OH2. Identification of amines is based on the interaction of the mixture, organic mixture with HNO2 acid, and also another color test to identify ethanol amines, which is based on the color test with chrome dye. So this is the scheme of the algorithm I propose. In my work, I also analyzed metal working fluid for introduction of American production, Garia M22. This is a mineral oil based with the viscosity 22 centistokes at 40 degrees. We have measured its base number. It is 12 milligrams KOH per milligram. And measuring the acid number, we prove the absence of acids. We then completed the Kedov reaction, and it showed us the absence of amides. We took a sample and analyzed it in IR spectroscopy and found some peaks and proposed that the solution may have esters, azo groups. We also saw no OH peaks and no amides peaks, so we say that these components do not exist in our mixture. And by atomic emission spectroscopy, we identify zinc, calcium, sulfur, and phosphorus. So taking into account the components that typically used in metal working fluids formulations and the data that we got from our analysis, we may propose the possible composition of the metal working fluids. So this is the base wall, which is paraffinic. These are esters as an extra pressure additives. These are CDDP, which is an anti-wear additive and also an antioxidation properties. Calcium sulfonate as a detergent and benzotriazole as a corrosion inhibitor. So finalizing my work, I would like to make some general conclusions. The algorithm and a number of recommendations permitting to identify groups of chemical compounds which the metal working fluid consists of are worked out. Given algorithm is applicable for both mineral oil-based and water-soluble metal working fluids, this algorithm is characterized by its simple use and can be fulfilled in almost any chemical laboratory. Although it has some disadvantages, so one of the greatest disadvantages is impossibility to identify all components, including their structure, but in many cases we even don't need it because it is impossible to make the copy of the product. It is impossible to find out the order of how the components mix, and this is also a very important part of the recipe, and we cannot guess it. And the last disadvantage is that the high qualification of researcher is required because it is really difficult to know all these methods and to run very good. So this is the end of my presentation. Thanks for your attention.
Thank you very much. Now our questions. Yes, please.
No question but remark. I say in addition to the statement that algorithm is simple, algorithm needed high qualification. Simple, no high qualification.
Now, I mean, the algorithm is simple, is that you don't need some very unique equipment. Maybe it is almost every laboratory. Almost every laboratory has the IR spectroscopy or any other method, but it is really, but high qualification is really required.
So this is an interesting exercise because that's what they call backward engineering. Yeah? When you have the final product and you need to understand what it is coming from. And it is interesting that it becomes a diploma work nowadays. It is very curious. And so, please, can you shed us some light on the product which you have tested finally? Could you come out to a recipe, in fact, or the findings which you have got in the end, have they helped develop a new recipe?
I haven't tried to make the same recipe. I just proposed the possible composition, but this is done to try to make something similar.
What
so
I would
maybe
do next is
I
would prepare a blend and then to compare it with the substance in question. Have you tried that?
No, I haven't.
No. It's next diploma work, yeah? Or next student, I guess. Okay. So what kind of test methods have you used yourself in this job? Or that would be just a theoretical job?
Mostly it was theoretical. I haven't conducted anything with myself, but the IR spectrum, for example, and the data of atomic emission spectroscopy I got from my colleagues from work.
Okay. So, more questions, please? No? Thank you very much. Thank you. So we are finished for today. We have heard all the presentations. So we ask our guests to leave us for a couple of minutes because we think we need to discuss together. Они там могут разрабатывать другую вещь.
Так, она работает на локальной International, и они этим и занимаются. Они создали вот эту часть, которую они создали специальное направление. Вот, кстати, немец изменил нашу.
Куда заменил? А наш немец?
Они немцы опустили. И он это самое. Задача его. То есть они приходят на завод, говорят, импортный станок с импортным сортом. Как это он делает какой-нибудь там панцирь, триумф и так далее? Не может быть импортный сорт. Давайте мы отечественный сделаем. Вот она. Приходит и говорит, а как это можно сделать? Я говорю, вот исследуй, как это можно сделать. Вот она сделала. Разведка. Импортозамещение, будет так говорить.
Да.
Она этот термин не употребила.
Самый случай, да? Она просто не знает, как это по-английски. Вот. А один мой коллега замечательный решил, там у них задача поставлена вот на нефтяной платформе, там есть кран, который поднимает большие металлические штуки, там определяет куда-то. Кран пока не может заместить. Но вот шпильки, которые он привинчен к платформе, вот это мы можем. Вот они взяли эти шпильки и пытаются воспроизвести на
Это сильно.
Продвигаются.
Это сильно. О чем манипулятор нельзя поставить?
Okay, so we continue now. So the examination board have concluded that all of you qualified for the master's degree or for the degree you are defending today. My congratulations. Let me tell you what are the scores. So Kошелева 96, Налетова 98, Котцова 98, Широкова 96, Трапезникова 90. So as you can see, this is very high score. My congratulations, this is 5 or more. We are proud of you. We think that you are the cream of the faculty and you have presented best works this year, we guess. So we recommend all of you to continue education, to go to the postgraduate studies, to master studies, any studies you want actually. So my congratulations, this session is almost over, but we need to do a couple of photographs, right? Yes. Кстати, не обязательно. Все?